Hello everyone, welcome to The Wild Side. This is your host, Dr. Kight, and I am finally back after a couple weeks away, so let's hope that I still know how to work all of the controls in here. Now this week I've started off with Bobby Darin singing Beyond the Sea. I'm sure most of you recognize that classic song. And the reason I played Bobby today is that I want to talk a little bit about marine pollution. And this is something that I was thinking about recently because I was involved in this event up at the University of Exeter where we asked the students to go out and make documentaries. And some of you, if you have been in Falmouth and you're in town, you may have actually encountered some of these students because we sent them out into the community and asked them to ask people, locals, what they felt about certain issues. And marine pollution was one of the big issues that we wanted them to look at, because we're here on the coast and we're here in a coastal environment in general that can really be affected by lots of different types of pollution. So whether that's chemical stuff coming in from the streams and the rivers, or whether it's things like plastic that are coming up on the beaches because of the tide, whatever the case might be, we do see a lot of that down here, and it can really impact whether we have tourists that want to come back because the beaches might not look as pretty if there's a lot of trash. It can also impact kind of the health of the landscape if we're bringing in lots of pollutants. And so we just wanted to get an idea of how people perceived this problem here in Falmouth. And unfortunately the videos aren't up quite yet that the students produced from all of this, but they will be soon, and I'll put a link to that on the Wildside website because it's really interesting to see what locals feel about marine pollution here in the area. And we also interviewed some tourists that came in that we encountered along the way. So you'll find out a lot about kind of the Cornish attitude towards this issue and kind of the Cornish, the impact on Cornwall of marine pollution. And so today I kind of want to expand on that idea and think about it in a little bit more detail and kind of look more at the science behind marine pollution and not so much the social aspects and implications. So back in the day, in the last 20, 30 years, people used to think that basically the solution to pollution was dilution. This was a little catchphrase that someone developed in order to kind of just describe the attitudes that used to prevail about what we should do about toxins and other pollutants going into the ocean. And really the idea was that you didn't need to do much of anything because the ocean is huge, there's lots of water, the amount of pollution that's being dumped into it is very small relative to how much water there is. And so really there's nothing to worry about. The water will just take care of it. It will sink to the bottom. It won't be an issue. And of course we know now that this is not true at all. Even though the oceans are incredibly vast, they do in fact suffer from the contaminants that we dump into them. And we've been learning more and more about this process over the years, and especially within the last, 10 or 20 years, when we've become really aware of the potential negative implications of all the human activities on the habitats that we live in. So actually what's really interesting is that humans have been impacting the ocean for a really long time. Now obviously, you would expect that to be the case because we've been around for a long time. But this goes back to before even the Industrial Revolution, which we often tend to think of as kind of the point in history when suddenly our impact became much larger and more obvious and more negative. And there is in fact some evidence of humans putting pollution into the ocean in a very negative way, having a noticeable impact, even as far back as the Roman times. And of course this has accelerated over the last 3 centuries since then. And basically marine pollution involves lots of different pollutants that have become increasingly common since the Industrial Revolution, and that's why that is kind of an important benchmark, because these are things that were developed at that time, or their manufacture became possible because of the technology that was developed then, and so we're seeing more and more of them. And one big component of this kind of general category of marine pollution is the chemicals that are associated with agriculture. And these include pesticides and herbicides and fertilizers. Also other chemicals, so things like detergents and oil, sewage and solids, so things like plastic and old fishing nets. And then of course there are also there are some pollutants that can float at the surface, but then there are other pollutants that collect at the depths. And these can be eaten by microorganisms, and then those microorganisms are eaten, and so on and so on. And so some of this stuff can be introduced into the food chain. It's not just hanging around in the water. And some of it can actually even end up in us if we are eating seafood. So some of the heavy metals that we're worried about, for example, because of eating salmon or other fish, one of the reasons that that heavy metal is in the fish to begin with is that we've introduced it through some of the contaminants that we've introduced into the water. So not only are there different types of pollutants, there are also different places that these are found. And one increasingly interesting area of research is looking at the different ways in which these pollutants can cause problems. So some of them, I've mentioned before on the show, that horrible thing that happened a few months ago in the winter when those chemicals were dumped out off the coast of Cornwall and Devon, and they coated the birds in that kind of oily, sticky substance, and they couldn't fly. So you have a lot of events like that where contaminants are floating on the surface and coating individuals and causing them either extreme harm or causing death. Then you've got the case where you've got things that can entangle organisms, or you've got chemicals that maybe will be toxic and kill off certain species, or maybe encourage the growth of others so that they can exclude certain species of interest. And then another real problem is the fact that sometimes animals will eat things that they think are food when in fact they aren't. And this is obviously the biggest problem with solid waste. And one really common type of solid waste is old fishing nets. So wildlife might go to try to eat these things, maybe thinking that they're worms or snakes or some kind of normal thing that they would eat that has that general shape. And in the process, they can get entangled. And the problem with this is also that they are acrylic, most of these fishing nets, and they can last for a really long time. And so ultimately what they do is a process that's known as ghost fishing, which means that even though no fishermen are using them to capture any prey, they are still trapping lots of animals. And that also can be because the nets will capture other species that then these predatory species will come in and try to eat. So there are lots of problems with kind of entangling and trapping animals. One really horrible thing is how some species of seabirds, in particular albatrosses, are known to go out and even preferentially look for plastic items that they think are very easy prey, and then they'll take them back to their young in the nest. And some researchers have found dead bodies of young, gulls, albatrosses, all sorts of those seafaring birds. And their stomachs will just be full of these different plastic items. And basically, a lot of these guys have starved to death because they've been fed quite a lot, but all of that food is not really food, it's plastic instead. So this can be obviously a really horrible problem for certain species of marine life. Now also there are some kind of non-conventional types of pollution that are to be worried about, and I've mentioned some of these before on the show. So things like noise pollution and light pollution can also be problematic. And lights often come from boats and also things like oil rigs that are left out for a long period of time. And in fact, these things are so successful at attracting animals and luring them into places that they might not ordinarily be, that some fishermen actually actively use lights in order to capture animals of interest. So for example, squid fishermen in Asia, particularly in Thailand, are known to use light to draw in species. And you can actually see these things from space. So if you go up and you look at the satellite images, you can find these massive areas of light where all the fishermen are congregating and using those lights to draw in squid. And people are aware that this is a problem. Lots of marine conservation organizations have suggested certain tactics to reduce light pollution. I'm sure the marine organisms would also suggest them if they could talk. So one example is on the boats that people go on for cruises. These things are really lit up because of course they want to protect the health of the people on board. They're looking out for safety. They want to make sure that no one accidentally falls over the edge in the middle of the night. So they're extremely bright. And lots of people are suggesting that, it would be very easy to just put a little cover on the outside of that light so that all of the light is deflected in towards the ship. It doesn't go out towards the sea. And then it's not exposing the animals to that. It's not drawing them into the ships, and it would then keep them safer. And as I mentioned earlier on the show, just like you've got problems with light pollution wherever ships are going, you've also got problems with sound pollution. So things from passing vehicles can be quite loud. It can get in the way of the signaling of certain marine species, things like dolphins and whales, are particularly susceptible. You also can have injuries from pile driving. So pile driving is where they ram those massive things down into the soil in order to build structures out in the water. And that can be extremely loud, to the point that it actually will burst the air sacs within certain species of animals, or just cause them quite a bit of discomfort, make it harder for them to hear, actually permanently deafen them in some cases. And this all can be very stressful as well. So obviously there are lots of things that I could talk about. I could go into lots of detail on any one of these topics. But one thing that I'm particularly interested in is the solid pollution. And this is something that kind of sparked my interest because I was recently reading this really wonderful book that I picked up at the Falmouth bookstore. And it's written by a local, so it's a woman who went around Cornwall for, I think she said, 4 or 5 years, and just collected tons and tons of photos at all of the beaches. And she's put together this beautiful book that's really artistic, and it shows all of the lovely scenery around here. But it also profiles lots of the different species that we encounter along the shore, and it talks about kind of the processes involved with coastal dynamics and rocky shorelines and the organisms that we would find and how they kind of relate to each other and to the habitat. And a couple of the pages in the book are devoted to thinking about the flotsam that washes up on shore and the process by which all these little things from out in the ocean wind up on land and what impact they have and kind of the implications of pollution as well. And so I was reading this book and I got my curiosity piqued by a few details that she mentioned, and I'll discuss a little bit more later. And so I spent the weekend looking into this issue of what happens with all of this solid pollution. Where does it go? How long does it take to get places? Is it always bad? Can it sometimes be good? And so I just looked into all of these details, and that's what I want to share with you guys today. And really the first step in understanding the impacts of solid pollution, and in particular, you'll probably find that I say plastic a lot because one of the primary types of pollution you find is plastic. First you have to understand ocean gyres, because these are the things that are responsible for carrying and also concentrating big areas of trash in the ocean. So gyres are areas where ocean currents are spiraling around a central point. And in the northern hemisphere these things move in a clockwise direction, and in the southern hemisphere they move counterclockwise. And there are 5 gyres on Earth. These are the North and South Pacific subtropical gyres, and the North and South Atlantic subtropical gyres, and then there's also an Indian Ocean subtropical gyre. And the one that's been studied really well in the context of pollution is the North Pacific subtropical gyre, which is really not easy to say. Don't try to say that too many times in rapid succession. So this thing is made of 4 different currents: the North Pacific, the California, the North Equatorial, and the Kuroshio. And there is actually some research that's beginning to come about for the South Atlantic subtropical gyre, but this is the one that's really well known. And the North Pacific is estimated at being around 7 to 9 million square miles in total, or to put that into perspective, about 3 times the area of the continental US. And this gyre is particularly likely to collect debris, but the debris does not cover that entire area. So it will kind of move around and it will concentrate in certain spots. There are some things that you're more likely to find in some places than others, and there are some times when it might be really spread out, all the trash across this area, but other times when it comes more together. And all of this is a result of the undulations in the water that are caused by kind of wind and currents and storm fronts and all sorts of things that interact to move these things around. And these are also known as frontal meanders. So the frontal meanders are the changes that you kind of find as a system is moving in and out. And there are also even smaller scale things, so like little eddies in the marine habitat that can also affect where the trash is and what type of trash is there, and whether it's congregating in big amounts or it's just a few little things here and there. And whenever you do find these aggregations that are all in one big spot together, they're known as garbage patches. And that's, as you might expect, a bit of a misleading term, because I've just said that these things can be strewn out all over the place. They can also be kind of more closely knit. You can see this stuff in some cases, in other cases you can't because it's quite small. So really describing it as a garbage patch isn't quite the right way to go about it, because that makes people imagine that you've just got a whole bunch of really obvious trash just sitting and floating on the top of the surface, and that's not the case at all. But this is a term that was coined by the media, and it's caught on really well. And in fact, if you do go around and ask people about these marine garbage patches, they probably have heard about these problem areas in the water where you do have these vast accumulations of debris. And I'm going to talk a little bit more about this after the break, and think about the sorts of things that are in there, and also where it all goes and how it all gets there. And that was Jim Lauderdale with Trash Can Tomcat. And that is a song that always gets stuck in my head whenever I hear it, so I'm sure I'll be singing it the rest of the afternoon. Now, before the break, I was talking a little bit about kind of the generalities, let's try that again, of marine pollution. And now I want to think more specifically about these marine garbage patches, which, as I kind of indicated earlier, are mostly studied in the North Pacific subtropical gyre, but are increasingly studied elsewhere as well. So some of the information that I'm mentioning in this next little section may be more broadly applicable than just thinking about that one little ecosystem in between kind of the Japanese coastline and North America. So marine garbage patches are these concentrated areas of marine debris. And this is a term that's generally applied just to that North Pacific area. Other areas that have lots of trash are just kind of generally referred to as, having marine debris. So if you ever do hear this idea of the garbage patch, most people are specifically referring to that one area in the marine habitat in general. Although, as I mentioned before, these kind of same dynamics do apply globally. This area in the North Pacific Ocean is also sometimes referred to as the Pacific Trash Vortex, so that's another name that you might hear bandied about. Now, one of the things that I mentioned before the break, when I said that there are these awful pictures of these poor seabirds that have ingested lots of plastic, is that one of the major problems with this type of stuff out in the habitat is that it can be ingested by things like turtles and seabirds, and there's a lot of anecdotal information about this process that's happening in the Atlantic in particular. So although this is known to be a problem kind of generally, it has really only been studied in these two areas, and it's likely that actually this is a problem around the world, that wherever you have this marine pollution showing up, you do have these poor little local animals that are mistaking it for something that they can eat, and then having problems associated with that. And so this is the kind of thing that we need to really look at more in detail, because these local stories that we have from the Pacific, and increasingly now from the Atlantic, are probably true around the world, in the Indian Ocean, in the southern hemisphere, as well as the northern hemisphere, potentially even in the Arctic, if the debris does make it that far south and north. And so we do need to kind of look at these things in a lot more detail, but we do know some stuff kind of, as a good baseline. So for example, a lot of the debris in the garbage patches are very small pieces of things. So they aren't these massive, oil drums that have fallen off of a ship. It's not a bunch of, one shoe from a pair or that sort of thing, even though that is what you tend to find if you go walking along the beach. So most of the stuff that we do find out in the ocean is little stuff. And sometimes that's because it started out bigger and was just slowly worn down over time. But also that tends to be the case because the big stuff will kind of wash up on shore earlier on, and it's that little stuff that's left behind to keep floating around and causing problems. And I'll talk about plastic specifically a little bit later, but plastic does seem to be a really big problem because it does hang around forever. And so whereas you've got things like wood or fabric that would eventually be worn down and degraded, that's not the case with plastic, and so that's why it's a high percentage of what we find out in the seas. Now, you might be interested in knowing specifically where some of the garbage patches are. So in the Pacific area, you've got basically the Eastern Pacific garbage patch and the Western Pacific garbage patch. Not surprising, I suppose. So the Eastern Pacific one is about midway between Hawaii and California. and this area is known as the North Pacific Subtropical High. And it's an area that rotates and moves and changes a lot over time. And so that pushes the garbage around the ocean a lot. So the patch is not always in one place. It's actually kind of a moving thing. And in the Western Pacific Garbage Patch, this is an area that's known as a recirculation gyre. And the specifics of this were a bit hard to track down, but I think the basic idea is that it's stuff that has been in the ocean for quite a while, and it's picked up and just keeps going over and over and over again. And so it kind of floats in from other areas and is kept there in this current where it just keeps going around. So it's not the kind of stuff that would eventually be washed into land somewhere. It's just kind of perpetually hanging around in the environment. And again, this is all caused by a combination of wind and ocean movement, but a lot of work is being conducted right now to try to understand this process in more detail. Now, in both of these areas, a lot of the debris is actually just beneath the surface of the ocean, and so you can't really see it that well if you're just kind of driving through on a boat. And in fact, a lot of people tend to think that if we do have these massive areas of garbage out in the ocean, we should be able to see that from the satellite, because it should cover enough space that you can look down and see maybe a big patch of gray or white or black or some kind of smudgy thing that would indicate that there's a lot of garbage there. But because it's all sitting below the surface and because it's often quite small, it's actually practically impossible to see on satellites, which makes cleanup obviously quite a difficult concept. Now, another thing that's important to know about in this kind of garbage patch area is the subtropical convergence zone, or the STCZ. And this is an area of the North Pacific where you've got a whole lot of debris, but also a whole lot of wildlife. And so this is one of the regions where it's most problematic that we have this kind of convergence of bad things that are causing harm and species that we really want to protect. And there's probably a similar area in the Atlantic and in other locations as well, where you've got a lot of diversity and a lot of abundance that you want to target your conservation efforts towards, but then that's also where you've got kind of this overlap of where the pollution is ending up. So this is obviously quite a dangerous situation. And this area is extremely productive. It's got lots of species migrating through and feeding there. And like the other areas that I mentioned earlier, the Eastern Pacific Garbage Patch in particular, the STCZ moves seasonally. It's affected by El Nino and La Nina, and it's affected within a year because of the different changes in temperatures and winds and currents. And so you find that the boundaries of where the STCZ are, or is, and also the sharpness of those boundaries, that can all be affected by these temporal changes, which again can make it quite difficult to find the garbage patch and to study it and to predict how it's going to affect the organisms that are there, because you don't even know where there is all the time. Now, Hawaii is particularly problematic in terms of marine garbage. You have tons of debris that tends to wash up on the shore of Hawaii, and that seems to be because of the location of the STCZ. It's very close to Hawaii, and it's very active, and so it brings really high concentrations of marine trash close to the Hawaiian shores, and from there you've got all of that garbage kind of washing in and ending up on the seashore along the coast. And this is, again, a really big problem because Hawaii is a huge tourist destination. It's an area where you've got lots of people out in boats. It's an area where you've got lots of wildlife. And so having all this trash out there can be quite dangerous for navigation. It can threaten things like the protected Hawaiian monk seal and all the sea turtles and seabirds and whales that are around. And that's important not just ecologically but also economically, because a lot of the tourists in Hawaii do go there because of the environment and the habitat and all the amazing species that are there. And if you've been following the news, then you might have noticed that Hawaii has had a particular problem with sea garbage since the Japanese tsunami that happened in 2011. And there was this really interesting lag where the tsunami happened and they knew that lots of debris had been washed out to the ocean, but it didn't show up for quite a long time. And then little by little it started to trickle in. And a bunch of it has ended up in the U.S., kind of along the continental U.S., I mean, and it's kind of found its way to the Oregon and Washington area, and also the southern part of Canada where it meets the U.S. border. But what hasn't wound up there, and what's not still floating around in the gyres, has really come to Hawaii in massive numbers. And there's this picture that I found of a very recent thing that wound up on Hawaii. It was this massive drum that people think maybe was used in creating some sort of a dock or other floating thing in Japan. And so, although some of the trash is quite small, you do also get these massive things that can be quite dangerous if they're rolling about out in the seas and then being flung up on the shore. And so that's why this is a real concern, particularly because a lot of it is thought to still have some active radiation. So researchers are attempting to create some models that can predict where all this debris is going to be found. But even though they've done this with some success, a lot of it still appears without warning. And so they're trying to use all of these patterns to understand better what's happening out in the sea and to get a clearer idea of what the kind of currents are and how long things are going to last out there, whether different types of objects are treated in different ways. And all of this could maybe be a beneficial outcome of what otherwise is quite a disaster. And I'll talk a little bit more about that here after the break, because it is quite interesting how you can kind of make a really bad situation into something that's quite valuable, so that in the future we can learn from these things and kind of expect what's going to happen and kind of plan better for it in the future. So one of the other things about this stuff that has been found in Hawaii is it's quite interesting to look at different types of objects that have been found and when. And what's become really clear is that the higher you stick up out of the water, the more you're going to be blown by the wind and moved by the wind. Whereas the lower you're down in the water, you're going to be washed towards Hawaii or still circulating. And this was something that researchers did already kind of know, but the Japanese tsunami experience has very much firmed up these patterns. And it's quite interesting to see how the larger items, or the items that are kind of awkwardly shaped and stick up out of the ocean, do get moved much more by the wind than by the currents. And you can then kind of use that to predict what sorts of things are going to show up where, which would then allow you to maybe have an idea of how big of an impact the debris will have once it does show up. So I think that's all I'll say for now about kind of marine garbage patches in general and some of these things that can move the marine trash around. After the break, I want to talk a little bit more about plastic, which is really the thing that we need to target the most in terms of minimizing its impacts in the marine habitat and maybe trying to clean it up a little if at all possible. And that was Gorillas with Plastic Beach. Now, plastic, as I have mentioned already several times, is particularly common amongst all the other marine pollution types. And what's interesting is we use the word plastic and kind of, I think, envision what that means in our minds, but it actually can be lots of different things, and you probably don't even realize all the different types of products that are really within that category of plastic. So it really can be anything from styrofoam to plastic bottles to trash bags. So the really light, thin stuff all the way to the heavier stuff that's really heavy duty and will last quite a long time. Well, I mean, all of it lasts a long time, but the bigger it is, the longer it takes to wear down. So it's really a huge range of stuff. And of course we use tons and tons of plastic, and although a lot of us do try to recycle, just massive amounts of it do wind up going to the landfill, and a lot of that stuff, especially in islandy places and in places where you want to have the trash off of the mainland and somewhere else where no one's going to see it, it can be transported across the water before it's gotten rid of. And when that happens, a lot of times you can have things that are spilled, things that just kind of blow off or roll off. Even when you're inland, you've got things that can kind of eventually work their way into a local stream and then go to a river and then from there into the ocean. So there are lots and lots of sources of all the plastics that wind up in the water. And these tend to float, obviously, and that can help them stay in the water and not get tossed up onto land or kind of dragged down to the bottom. They're very colorful, which makes them very visible, and so it's something that we do notice quite a lot once it does make it into the water. And as I mentioned earlier, they generally don't ever go away. They just get smaller and smaller and smaller, even to the point where it's hard for us to see them, but they are still there. And so that is extremely problematic, especially in the ocean, because the ocean is cool and there's not as much sunlight, And both of those are things that are that can have an impact on how long it takes for things to degrade. So you want to have the biodegrading sorts of activity to happen in places where you've got lots of sunlight and lots of warmth, because those are things that accelerate the action of these organisms that do biodegrade things. And when you don't have that, then these things can sit around in the environment forever. And particularly problematic is these pea-sized resin pellets that are also known as nurdles. And nurdles are some of the most common types of pollution. And there are actually some beaches in the world where you've got just nothing but nurdles. And if you don't look closely, you might not notice the difference. You might think that it's kind of weird sand or really tiny cobbles, but actually what it is this little tiny pellets of plastic that are heated and stretched out in order to make things like plastic bags and other kind of plastic products, because you can also put lots of them together and melt them together and make the larger, heavier stuff as well. So this can be obviously quite a problem, especially when you've got things that are filter feeding, so things that will kind of pull in all the stuff that's in the aquatic environment and filter it through their gills. That can kind of be very abrasive and hurt them. Once they have it in them, it can be quite hard to get the plastic out, and so these organisms will carry around a lot of plastic. There have been even some stories of organisms that will ingest a big enough piece of plastic that is quite buoyant that it will make these things float higher up than they should be, and they're not able to dive down. And that's something that you do particularly here with sea turtles, which is quite sad. I actually saw one of these turtles that had an issue. I forget what it was that it had consumed, but there was some sort of a plastic thing that it had ingested, and they were unable to do a surgery to get it out. And so this poor little guy was just bobbing along the surface, and they nicknamed him Bob. And they were hoping that eventually, he was at a sea sanctuary, so they were hoping that eventually he would pass it out of his system in some way or another, or it might be degraded enough that it would maybe no longer be such a problem. But because he was like that, he couldn't survive out in the wild because he couldn't dive down and get food. And so they had to feed him at the surface of the water. And obviously any animal that's out in the wild like that wouldn't last very long because it would starve to death. So this can be really problematic, not just for the gill feeders, but also anything that would ingest the plastic and then swallow it. You know that plastic can have very sharp edges, be quite uncomfortable, even if you're just trying to, twist off a bottle cap or something like that. And so these organisms that eat them and have that plastic moving around in their system, they can really suffer the consequences. And if they do this too much, they might feel full and think that they've eaten everything that they need, when in fact they still need lots of nutrients and food, because that plastic is just making them think that they've had everything that they need. Now, another problem with plastics is that they're full of pollutants, and they absorb these from the environment. So things like PCBs, for example, or polychlorinated biphenyls. These were banned internationally by 2001, but they can still be absorbed in these plastics and then leach out and potentially cause more damage, although more work is needed to really understand the extent to which this is a problem, and all the different chemicals that may or may not be absorbed and held by these plastics. Now earlier I mentioned that it might be of interest to try to clean up these garbage patches, but actually there are a lot of problems associated with this idea. For example, garbage patches move throughout the year, as I've already mentioned, and they'll move from one year to another, so it can be quite hard to locate them. They can be extremely large, so you can have the trash spread out over really massive distances. And so it would be difficult to reach these areas, to navigate through them, to have enough resources and enough ships to send out to actually cover that whole area of space. The debris is also not distributed evenly throughout the patches, so you might be able to collect a whole bunch in one area, but then you need to find the next area where it's located, and you could be boating around for days and days before you ever find it. And all of this, of course, would cost quite a lot of carbon and quite a lot of money, because you've got to get all these ships out there to these areas. You've got to keep them moving around for days or weeks or whatever it would take to do all of the cleanup, and that can have environmental consequences also. And then even if you were to be able to do all of this, a lot of the debris can be really difficult to collect. So those bigger pieces would be quite easy to probably just swipe up in a net. But if you've got all that little microplastic stuff, so the things that are really small that are being ingested by the fish, for example, that could be really difficult, because what kind of net is going to be small enough to capture all of that? How would you strain it out? And even if you did, what would happen to the little microorganisms that are also in that water sample? So, for example, one real problem would be the fact that you've got plankton that are about the same size as these microplastics. And plankton are the base of the marine food web. They do about half of all the photosynthesis on the planet. And if you disrupt these guys when you're trying to get the plastic out, then you could have really serious implications for the other marine organisms that depend on them. And that is pretty much all marine organisms, because of the impact that plankton have on the overall food chain. And then toss into this the idea that debris is often found in places where really important species live, or where human disturbance would have a really bad impact. And you've got a really tricky problem on your hands, because you need to try to balance out the good and the bad of potentially going in and getting rid of this garbage. Now, as I mentioned earlier, it's not necessarily all kind of a depressing, sad story. And that's because, as shown with the case of the Japanese tsunami, you can actually take advantage of the presence of this garbage in the ocean and use it as an opportunity to learn about how the ocean functions, where are the currents, how long do they take to go places, all these sorts of details that are otherwise quite hard to get a handle on. And in the past, the way that researchers looked at this was to deliberately dump a bunch of stuff in the ocean, if you can believe that. They actually used to have, for example, little plastic tags that they would number and date and then toss into the water, and then hope that they would wash up somewhere or be seen by someone, and then whoever would find them or see them from the shore would call up, NOAA or whatever organization was doing this, and tell them which one they'd seen and give the identifying number, and then researchers could kind of use that information to track the progress of these things around the planet. But you don't just have to wait for the funding to do these specific studies on these specific tags. You can actually take advantage of whatever stuff happens to be dropped into the ocean anyway. And that is because you can take advantage of flotsam. And flotsam is the floating wreckage of a ship, or the cargo of the ship that is left behind as a result of some sort of an accident. And this is a part of the world in which we have lots of flotsam because of all the wrecks that have occurred here. So you're probably really familiar with this. You've probably seen lots of it. And flotsam facilitates this kind of accidental oceanography. And one of the big sources of this is when you've got these cargo containers. I saw a statistic that said that approximately 100 million of these are shipped every year, and of those, thousands fall overboard annually as these ships are making their way from one continent to another. And I have to say, I'm really glad that I saw this statistic after moving from the US to the UK, because I sat around for 3 months just praying that my stuff was eventually going to get here. And if I'd known what a high rate there was of those things falling off of ships, I probably never would have been able to bring myself to send my things by boat. But anyway, a lot of these things do fall over, and then all of those items that are in them are inventoried, and so you know where they came from, you can kind of get an idea of where they fell overboard, you know where they were headed, so you can do lots of really interesting math as you follow these items in their path after they've fallen off the ship. So for example, in 1990, in the mid-North Pacific Ocean, there was a container of Nike sneakers that fell overboard, and there were 80,000 of these shoes in the container. And researchers noted that each shoe had a specific code, so they knew where it had been and where it was going. They knew what shoe was what, so they could distinguish between the shoes, even though they looked kind of the same. And so they were then able to ask beachcombers to report the codes from each of the shoes, and this allowed the researchers to determine how frequently the shoes kind of were lost forever, how long they could last, to kind of get an idea about the pathway that the shoes were traveling as they were carried on the ocean currents. A similar thing happened in 1992 when there was a load of plastic tub toys that fell overboard in the mid-Pacific, and this time around there were 28,800 of these things, and they were specially designed tub toys. I can't believe there is such a thing, but they were kind of a limited edition sort of thing. And so again, they were very recognizable, easy to track, and an oceanographer from NASA was able to track the toys for 14 years, and actually some of these things still show up even now. So it's been quite a long time, but they're still floating on the ocean and making their way around the world. And the thing that got me really interested in researching all of this was reading in that book that I bought at the bookstore, which I'll put a link to on the Wildside webpage, because it is a great thing to have if you're going to spend any time on the beach here in Cornwall. So the author was writing about how there are these things called collector beaches, where beaches have kind of a tendency to collect certain types of items. So not only are there some beaches that are more likely to have flotsam than others, but there are also some beaches that are more likely to get particular types of flotsam. And it's really interesting to find out why it is that these things specialize. And really it has to do with those things I mentioned earlier about how the things with the weird shapes that stick out of the water, those tend to be moved by the wind. Things that sit a little bit lower tend to be moved by the water. And then you've also got not just the shape, but also how buoyant it is and whether it's going to be lifted up or sinking down low. And so all of this together can affect the speed and also the direction of where certain objects are going to wind up. And then you've got also local currents and local geography that are responsible for driving particular items to particular parts of the shore and not just in any one specific place along the coastline. So that could be the difference here, for example, from landing up on Castle Beach versus Gilly Beach versus Swan Pool. And that could be any subtle little thing because of the variations on the seafloor or the cliffs and how the cliffs go down into the water and change the currents. So all those kind of little local geographical features can really influence these patterns. And the author of that book mentioned this fantastic study that found that right boots and left boots tended to have a different path, I guess, once they fell off of fishermen from the North Sea. So right boots were more likely to end up in Scotland, and left boots were more likely to end up in the Netherlands. And all of that was just because of that slight difference of the shoe shape, the foot shape, and the way that it just makes the currents move the shoe in a different direction. So one goes east and one goes west. And this is kind of reflected also in Hawaii, where you've got these traditional beach names that reflect the type of thing that would wind up on the shore. This is actually kind of a depressing example, but it's really interesting nonetheless, where they named one beach, and here I'm translating from the original Hawaiian, one beach was the twisting water washes ashore royalty, and another beach, which was very nearby, was known as the twisting water washes ashore commoners. And this reflects the fact that when someone would fall off of the cliff, or would commit suicide or be shipwrecked out in the water, bodies would show up in different beaches depending on whether they were larger and richer, so that's the royalty, and whether they were smaller and poorer, so that would be the commoners. So basically it's just the subtle difference of how much money you have, driving how much food you can eat, driving where your body would wind up on the shore if it were in the water. So it's amazing how, even very long time ago, people who were living on the land near the sea could recognize these differences in how the currents treated the stuff that was washing up on land. And interestingly, this area in Hawaii that I was just referring to, that whole stretch is now referred to as Plastic Beach because it has so much plastic that's now been washed on shore. And I guess in this case, it's probably slightly better to have plastic pollution than to have the bodies of people that have fallen off a cliff nearby. So that's one other, I guess, very strange pleasantry of having some pollution. So one other interesting thing that people have found by studying this flotsam is that you can have certain objects that are able to travel entire current paths. So they go across the entire global conveyor belt, which is a massive area of space. So there have been things like tub toys and sandals and pumice from volcanoes and messages in bottles and things that can go the entire 12,000 kilometer subarctic gyre, for example. And that particular pathway was found to take about 3 years. So about 4,000 kilometers a year is pretty impressive. And all this information can be used by scientists who are hoping to understand what's going on out in the oceans, so they can make projections about climate change or about how certain weather systems might impact marine travel, or about lots of other things that that can impact us because of storms and because of things like the tsunami and where's the debris going to go. So these can have really practical applications. And all of this information actually relies a lot on beachcombers. So beachcombers are known to work together in international networks, and one of these was founded by this guy that I mentioned earlier who works at NASA, and it's known as the Beachcombers Alert. And this brings together people who can tell each other about where there are spills and what the hot spots are for finding this stuff, and they go out and they look for it and then they report back on what they found. So not just the spilled items, but also things like crustacean tags, so the tags from lobster traps, for example, devices that have been released from previous studies, so like those little plastic tags that I mentioned that are still floating around. Sometimes they can report those in, and they can give all of this information to people so that they can analyze it and understand about these currents. And if you didn't have this huge network of thousands of people contributing, you probably wouldn't be able to do any of this modeling because you wouldn't have nearly the sample size that you need to really begin to understand where the stuff goes and how long it takes to get there. And what's amazing is the stuff that we do now actually builds on a long tradition. So even back in the 1870s, we had people who were deliberately throwing out messages in bottles in order to see where they would wind up. They were looking at volcanic pumice after it erupted to see where it went and how long it took to get there. They also were looking at drifting vessels. So back in the day we had a lot more strandings than we tend to have now, ships that were just permanently left to float free forever. And so people were able to study this in order to understand, actually in order to kind of find for the very first time these subtropical planetary gyres and these other really massive things that, they had no satellites at that point, so this was the only method they had to really understand these really large-scale processes. And amazingly, a lot of this stuff, these things that can ride the entire global conveyor belt, not melt, they can be at sea for 20 years in total, circling the entire globe. So obviously, understanding this stuff takes a lot of patience and a lot of good networking. And there's a lot of stuff online if you're interested in maybe doing a little bit of this yourself, because it is really useful work and it's quite interesting work. And I know that a lot of you out there are beachcombers, so it's something to keep in mind the next time you go out to enjoy the lovely weather that we have today, for example. So all of this stuff I will post links about on the Wildside webpage in case you want to get involved or kind of read more about it. And I'll definitely post a link to that wonderful book that inspired all of this as well. And I believe that's all for me this week, so I should be live again next week, and I look forward to talking to you then.